Hi everyone. So I will start in by 7:05. Okay. Let's wait for some more students to join. And hi everyone. So let's wait for some more students if they are joining or not. I don't know. So at 7:05 we'll start. Every time we'll start at 7:05 p.m. Okay. Hi everyone. So let's start the session. Okay. I am Vishakha Pandey. I am from one second. Yeah. I am audible to you, right? I'm audible to you, right? Yeah. You can tell me. It's okay. I am a student as well. Uh, I am a PhD student, but I am a student. So you guys can tell me. You don't need to be all. Don't um, judge me as a teacher. Okay. I'm your. I am as similar to you as a student and student will be. Voice isn't audible. Okay. Uh, okay. Sorry.
Okay, sorry. Ma'am, voice is not audible, ma'am.
Yeah, I got to know
Yeah,
that.
I got to know that.
Can you
Yeah,
mute?
now okay.
Can
Now,
you mute?
now okay, ma'am.
Yeah. So, sorry. So I was saying that, hi, hello. My name is Vishakha Pandey. I am a PhD fourth year student in electrical department of IIT Bombay. Uh, I am here as a PMRF fellow to give you a live session. Okay. So I don't want our relationship to be as a teacher and a student. I want our relationship to be as a student and student, right? I want to discuss with you everything related to the course, and I don't want you to feel shy. I don't want you to keep your doubts to yourself. Ask if you have any doubt, you can ask me. Good evening, Prajwal, right? So I would like to know hello, where are you guys from? Okay, I don't see anyone replying that. Everyone wants to start the session directly. Okay, no problem at all. So let's start the session. But okay, I don't want to give you the solution directly. Okay, I will give you the solution after discussing with you. So first I want you to attempt the question, right? Attempt in every possible way, and then someone wants to join this call. I don't know. Yeah. So I want you to attend the question in every possible way, whatever you think. No answer is incorrect without me giving you the answer. Okay, you try your best, and then we will discuss the solution. Okay, first you have to solve the question, and then after you try giving your 100% to the question, then we'll discuss the solution. Okay, all right. And my classes will be like I will be giving you the assignment question, the previous year's assignment question, and then you will solve it. I will give you some time to solve the question, and then we'll discuss. All of you will try to discuss the question, and then we'll discuss the solution. Is that okay with you? Trying anything to me? Yes, ma'am. Yes. Okay.
Yeah, yeah,
Chalo.
sure.
Okay. So, chalo, let's start. So, first thing is, you guys are from bachelor's, all of you, or someone is from master's, or someone is from PhD, or someone is a college teacher or something. Guys, I won't start if you won't give me answer.
Uh,
Working in an engineering college,
Hello,
ma'am.
ma'am. I'm Pradyumna.
Professor Jyoti Chitra, Dr. Jyoti Chitra
Hello,
from Tamil Nadu.
hello, ma'am.
Hello, hello.
Yeah, someone started
I'm working in engineering college.
working in engineering college. Okay, all right. What about others?
Ma'am, good evening, ma'am. Myself, Ilangosi. I am full-time research scholar and Madras Institute of Technology at Anna University in Chennai, Tamil Nadu. Ma'am.
Okay, that's good. Hello.
Um, I also teach in a college in Chennai. So
Okay. So everyone is from Chennai. Is that? uh,
I'm from Kerala.
oh, okay, cool. What about others?
Hello, ma'am.
Hi.
Yes, ma'am. I'm Mahapriya. I'm pursuing PhD at DIT, Vellore.
Okay. You are a first year student, second year student, or you are about to finish your PhD?
First year.
Okay. Okay. All right. Okay. Prajwal, where are you from? And what are you doing now? You are not audible to me, Prajwal. Okay, fine. Then let's start the session then. So we will be solving previous year's assignment one today. Okay, and I want you to bring your copy and pen so that first you will be solving and then I will be solving. Is that okay with you? Hello, let's start the session. my screen visible to you? Okay, hello Prajwal. Yeah, okay, all right. You are from Karnataka. Okay. So this is week 1, assignment 1, right? So is my screen visible to you all? Guys, can someone tell me is my screen visible or not?
Yeah, ma'am.
Ah,
Yeah,
okay.
ma'am, it's visible.
Okay, cool, cool. Thank you. Yeah, so the first question here is an infinitesimally small dipole is located at the origin and its axis coincides with z axis. Okay, so something like x, y, and z. Uh, let's keep this as z, x, y. Okay, and infinitesimally small dipole, right? And it is asked and it's in a Cartesian coordinate system. Then in the far field it radiates. So let's say it's a far field, and you have to tell if its radiation is uniformly in theta is equals to constant plane and non-uniformly in phi is equals to constant plane. Option A. Option B is uniformly in phi and non-uniformly in theta. Option C is uniformly in both theta and phi. And option D is non-uniformly in both theta and phi. So question is pretty simple. It is asking here is that a infinitesimally small dipole is located at the origin, right? And its axis is z-axis. Okay. Now in the far field, what will be its radiation? How its radiation will be varying in theta and phi coordinates? Is that clear to you? The question is clear to you? Hmm? Question is clear, right? Okay, first tell me, have you done the lectures, the 5 lectures that you were supposed to do from IT Kharagpur? Right? Okay, I'm going to give you 2 minutes. Try to solve this question. Think about it. How a dipole, right? Uh, how a dipole will radiate, right? If a dipole is there, how will it radiate? Are you able to visualize if this is a dipole? So how will it radiate, right? So theta, in terms of theta, you need to uh, uh, visualize, and in terms of phi, you have to visualize. And tell me how it will be radiating a dipole. Okay. So think about it and tell me what will be its possible answer, and then we'll go ahead. Yeah, I'm sharing my screen, so you are able to see my screen. So I'm going to give you a hint, okay? And hopefully then you will be able to tell me, okay? So this, uh, think of it as a dipole, right? And its field components here, it's phi, and this side it's theta, okay? And yeah, right? See a dipole, how a dipole will be radiating. This is some their 3D radiation pattern. This is the hint. Now I am hoping that you will be able to solve the question. Uh, take 2 more minutes and then I'll start as asking you what will be the answer. Okay. Done. Done. It's okay if you are wrong. Don't feel like I'm going to judge you or anything. It's all right if you are wrong. Just think and give me one answer. Okay. Just give me something. Is that okay with you? It's okay to it's okay to be wrong. It's all right. So think about it again, right? There is a dipole, Hannah, and uh, so there is a dipole, right? And it's basically asking it's radiating like the pattern and how the pattern will be varying, right? See phi theta. It's all right to be wrong. Yeah. See, okay, all right. What are other opinions?
Ma'am, I think it's D, ma'am. Option D.
Option D, okay.
D, D.
Option D, you are thinking, okay, okay. What about others? Option D, okay. What about others? What others think? Okay, so let's discuss the solution. So the answer is option A, right? Because see, the radiated power here, right? It's a donut shape, right? So all the phi values, for any phi value, it will be same, right? But for different theta values, the radiation pattern is changing. Are you getting my point? Like it's a donut shape. So if it's a donut shape, all the five values, for all the five values it will be same, but for the theta values it will be changing. Are you getting? If this is the radiator 3D radiated pattern. One second. Yeah. So option will be A. That is the radiated power in the far field varies with theta and it does not vary with phi. Okay. Now let's discuss question number 2. So a magnetic field strength of 5 microampere uh, per meter is required at a point on theta is equal to pi by 2, which is 2 kilometers away from the current element of length lambda by 25 in free space. How much power does the antenna transmit? Okay. So the question here is, there is a current element, okay, its length is lambda by 25. Okay. And at theta is equals to pi by 2, right, which is a 2 kilometer away. So this is a current carrying conductor. Okay. Okay. This is phi and this is theta. Okay. So at theta is equals to pi by 2, uh, which is 2 kilometers. So this is 2 kilometers, right? The strength of the magnetic field is how much? 5 microamperes per meter. How much power does the antenna transmit? So this is the antenna, okay, it's a current carrying antenna, okay, and it has a length of lambda by 25 at point, okay, let's say point is P, which is theta is equals to pi by 2 and 2 kilometers away from the current element of length lambda by 25. It's already written. How much power does the antenna transmit? Okay, so this is the question. So you remember, uh, if you have gone through the lectures, there would be a formula given for power, right? How much power a current carrying conductor gives, right? With the use of magnetic field which is already given to you, can you determine how much lambda it would, how much power it would be, power radiated, right? I'm searching for the exact formula for you to use. Okay. So I'm not able to find out the formula given in the lectures. Anyway, so this is formula to be used, right? Are you able to see this formula? So it's already written for a Hertzian dipole or a current element. The magnitude of magnetic field in the far field is given by this formula, right? So what is asking a current carrying element is given, right? And it is at 2 kilometers away from the current carrying element, and the strength of the magnetic field is given to you. So this is given to you. The strength of magnetic field is given to you, right? Uh, the length is given to you. Theta is given to you. R is given to you, and the whole formula is given to you. Will you be able to find out the value of the power? So first, what you have to do is you have to find out the I naught, right? All the other things are given to you. You have to find out the value of current, and then you have to put it in the power formula to find out that the radiated power. Okay, which I have, which I showed you this. So all the other terms are given to you. N naught is given to you. Dl by lambda naught will be given to you. For I naught, you have to find out using this formula, and then put all the values here, and you will be able to find out the value of power. Now solve the question. Okay, I'm giving you 4 minutes, and then we'll discuss. Yeah, solve the question and for 4 minutes, and then we'll discuss. Okay. First thing that you have to see is when theta will be pi by 2, right? From here you will be calculating theta, right? So when theta will be pi by 2, it will be, how it will look? It will look like this, right? The point P is here, and this length is how much? 2 kilometers. So you have to use this formula and this formula. very simple, right? You have to just put the values in the formula. Okay, take a guess. Take a guess. What can be the solution? Anyone? Yeah, where is K naught value, ma'am? K naught is a constant, right? Yes. K naught is a constant. What can be, what do you think K naught is? Guys? Hmm. Okay. 14.58 B. Okay. 14.58 is not the answer. On option B. Okay, all right. What about others? What others think? What is the value of K naught? Can someone tell me what is the value of K naught?
Is it omega by C?
Yes, it is omega by C. But ultimately, what will it come down to? Okay. So K naught comes down to
2 pi by lambda.
what?
Lambda, 2 pi by lambda, lambda by.
Yes, 2 pi by lambda. Yes, very good. Jyoti, yes, it's a 2 pi by lambda. The value of K naught is 2 pi by lambda. So now will you be able to solve? Guys, now that you know the value of K naught, will you be able to solve the question? Okay, see. Magnitude of uh, magnitude of magnetic field strength is already given to you. So H5 will be how much? H5 will be 5 into 10 to the power minus 10. This is given in the question. I naught is not given. DL is how much? Lambda by 25. So lambda by 25 is DL, right? Got it? Huh. Then K naught. K naught is 2 pi by lambda. 2 pi by lambda is here. 2 pi by lambda. Sine theta is how much? Sine theta is pi by 2. Already given to you. So you have to put the value of theta, which is pi by 2. What is left? R. R is how much? 2000 meters. 2 kilometers, which is equals to 2000 meters. So all the values are given to you instead of I naught. So you have to find out the value of I naught. You got the value of I naught. I naught's value is now 0.5 amperes. So tell me, how many of you were able to find out the value of I naught? How many of you were able to find out the value of I naught, guys? No one? Okay, now that you have found out the value of I naught, can you find out the value of power radiated? Okay, take out the formula. Okay, how do I just give you the formula? One second. I will do it. Ah, so this is the formula for power radiated. This is the formula for power radiated. Put it in the, you already know dl by lambda, right? You know the value of L, right? You know the value, you don't need to know the value of lambda because dl is in terms of lambda, right? Lambda by 25 is given to us. You know the value of I naught. Can you find out the power radiated? Everything is given to you here. You just have to put it in the formula and find out the correct answer. Okay. I'm giving you 2 minutes. Solve it and tell me. Let's see who gives the correct answer first. Someone has given already. Fast. Try to uh, put the values and tell me the value of radiated something. Try to put it on the chat box so that I can see instead of speaking, because it is possible that you are sitting in a noisy environment and I may not be able to listen to you. So put it in the chat box and I will be able to check. Okay, let's see who gives the correct answer first. Okay. Okay. What about others? Give fast. This is not correct answer. B is not correct answer. B is not the correct answer.
Ma'am, what is the relation between power in watts and dBm?
So dBm is a ratio, right? When we say something is in dB, we say that it is a ratio of something. Okay. dBm, you can, if you are, watts is a simple units of power, but when you put it in 20 log P, right, then it becomes dBm. The value becomes in dBm. Okay, so just the actual value, when you put the log, then it comes in dBm. Okay.
Okay, ma'am.
Correct answer. Fast. D. Okay. So time's up. So let's see. Yeah, it's a 10 log of the value. Okay. Who was asking me? 10 log of the value will be in dBm. Okay. Yeah. So option C is the correct answer. How? See, dl by lambda is already given to you, right? dl by lambda whole square to 40 pi square. Okay, dl by lambda will be 1 upon 25 whole square. I naught is already given you 0.5, so 0.5 whole square, so that becomes 158 into 10 to the power minus 3 watts. When we convert this into log, that is 10 log. It's a 10, it's not 20, it's a 10. So 10 log of this value, which is equals to 22 dBm. So the answer, correct answer is answer C. So tell me, someone got the correct answer or no one got the correct answer? Someone got it correct? Rajwal KM Alpha. Okay, you didn't get it. No problem. It's okay. You are learning here. Your goal is to get correct answers in the assignment which will be given to you this week, right? Not, you can have as many wrong answers here because it's a previous year's assignment. You can have that's why you are here. You are here to learn. It's okay to have wrong answers. You have to focus on the assignment which will be given to you, and there you have to perform better. So what is okay, so answer C is the correct option. C is the correct answer. Let's go ahead. So it's written question number 3. Yeah. So a Hertzian dipole of length, again, so again now see, again it's a Hertzian dipole. So a Hertzian dipole of length 0.1 meter is fed with a current 0.25 sine 188.5 into 10 to the power 6 t. So here the current is changing, right? Current is changing with respect to time. Earlier it was not changing, it was a DC current. Here the current is changing, okay, respect to time. So the current is 0.25 sine 188.5 into 10 to the power 6t. It's a alternating current, it's a AC current, okay. Hertzian dipole of length 0.1 meter is fed with a current. Determine the radiation resistance. So you have to find out R radiation. How will you find out? First, what do you do? First, you find out the power radiated by it, and then you get the R radiated. One thing is this, one way, or you can directly, if you have already gone through lecture 4 and 5, you know what is the formula for R radiated. You can put all these values and get the answer. Okay, so try to solve it. I will give you a hint after 1 minute maybe. Try to solve it now and then we'll discuss. Let's see who gives the correct answer first. Anyone got the answer? Okay, I'm going to give you the formula. Okay. This is the formula for R radiated, right? Either you can use directly the formula, or you can first find out the P radiated and then use it for R radiated. But okay, if you have gone through the lecture series, you know the formula for R radiated, right? So this is the formula. Solve it. Now that you know the formula, put all the values here and you will be able to find out. Okay, okay, very good, Ralph. That is the correct answer. Very good, Ralph. Yeah. Others also try to solve. Very good, Jyoti and Ilango. Very good. That is the correct answer. Yes, Shyama. Correct, correct. Very good, Prajwal. Correct. Very good, Sanket. Very good, all of you. So let's solve the question. So first thing is you have to find out the value of lambda, because here the value of lambda is not given to you, right? DL is directly given to you. It is not given to you in terms of lambda. So the first thing that you have to do is find out the value of lambda, right? But you know that k naught is 2 pi by lambda is equals to omega by c. Here the angular frequency is given to you, right? Lambda is not given to you. Can you find out the value of lambda? You know the value of c. C is here. C is speed of light. So pi by lambda is equals to 188.5 into 10 to the power 6 divided by 3 into power 8, right? Right. From here, you will be able to find out the value of lambda. The value of lambda will come out to be 10 meters. Value of lambda will be how much? 10 meters. By this value, you got the value. By this formula, you got the value of lambda. Okay. You will put it here. The value of DL you already know. So the value of DL you already know, which is equals to 0.1 meters. Value of lambda you know as equals to 10 meters. We'll put it here. All the other things are constant. We'll get 0.079 ohms. So R radiated is how much? 0.09 ohms, which is option D. That is 79 milli ohms. Option D is the correct answer, right? And almost all of you were able to find out the answer. So very good, all of you. Chalo, so that's a good thing that you guys were able to solve. Now let's try to again solve question number 4. So question number 4 here says a microwave source of 0 dBm power is connected to a current element of length lambda by 50. Again, notice, what do you have to notice? Here that the current element is given in terms of, the length of the current element is given in terms of lambda by 50. So you don't need to find out the value of lambda, right? Okay. Through a lossless transmission line with characteristic impedance of 50 ohms. Okay, so a source is given, right? It has a 0 dBm power. It's connected to a current element of length. So this is the current element which is of length lambda by 50, right? Lossless transmission line. So this is a transmission line. First a transmission line and then a current carrying conductor. Okay, 1 second. So lossless transmission line is given. Characteristic impedance of 50 ohms. 1 second. Okay. So a current element of length lambda by 50. So this is the length, right, of the current carrying element, and this is a lossless transmission line. Okay, and it has a characteristic impedance of 50 ohms. Okay, power radiated by the current element. Assume that there is no loss in the source end. So source end में there is no loss. Get it? microwave source is given with a 0 dBm power is connected to a current element of length lambda by 50 through a lossless transmission line with characteristic impedance of 50 ohms. Tell me, why do we have a transmission line with this kind of impedance? Can someone tell me why? Why is there a transmission line which is lossless and has a characteristic impedance of 50 ohm? What does this mean?
It means that it is a perfectly matched.
Yes, yes, very good. Who is this? Who am I talking to?
Compute.
Sanket. Yes, Sanket. Very good. So, yeah. So, a lossless transmission line with characteristic impedance of 50 ohm means that the power is completely transmitted to the current carrying element and there is no reflection of the power. Okay. Since it has a 50 ohm impedance. So, 50 ohm impedance means that the transmission line and the current carrying element both have impedance matching and there is no reflection of the power. So all the power is going to the current carrying element. Okay. Now determine the power radiated by the current element. Again, same thing. So we already know the P rad, right? The value of P rad. Now try to find out that. Okay, and then we'll discuss. You know the value of P rad, you know the value of formula for R rad. Try to solve this question and then we'll discuss. Okay. Uh, take 4 minutes. You know the value of R radiated, right? Try to find out what are the resistance R radiation will be, resistance of the current element. Find, then you will be able to find if there is a mismatch or a good match. 50 ohm ideally means it's a good match between the transmission line and the current carrying element. But it is possible here, okay, this current carrying element is not having 50 ohm impedance, right? So first try to find out the resistance of this current carrying conductor. Okay, then you will be able to find out if there is a mismatch or a good match. If it is a good match, then all the power will be coming to this element. But if there is a mismatch, then there will be a reflection coefficient. So the power from here, some power will get reflected back, some power will reach this element. Okay, and as per how much power it is reaching, then you can convert that power which will be in watts to dBm. Understood? Are you able to understand what I said? ठीक है, एक बार फिर से बता दूँ what I said. See, this is a 50 ohm. Okay, the current carrying conductor ideally has a 50 ohm resistance, and there is a good match between these two elements, and all of the power will reach this current carrying element. But first you have to find out if it has a good match or not. So how will you find out? You will use the R radiated formula. By the R radiation formula, you will be able to find out if the resistance of this and this is equal or not. If it is not equal, if it is equal and well and good, all the power will come to this, right? But if it is not coming to, if all of the power is not coming here, how will you able to find out that? By finding out the reflection coefficient, how much it is getting reflected. By then subtract it from the from the power source power, and you will be able to find out how much power this current has, how much power it is, this current element is radiating. Okay, समझ में आया क्या बोला मैंने? To solve, first find out R radiated, then reflection coefficient, then you will be able to find out P radiated. Okay, अभी solve करो. Done? Okay. Charts. हाँ, R radiation is इतना 0.3158 ohms. Okay. Yeah. Good. Okay, so first tell me how many of you knew that a microwave source of 0 dBm power means 1 milliwatts. How many of you knew that? Anyone knew that? No? Okay, I have already discussed with you how to find out the value of dBm, right? It was in milliwatts, right? This formula has already been discussed with you, right? If it is in watts, how will you milliwatts? How will you be able to find out it in dBm, right? So if it's given 0 dBm, will you be able to find out in terms of watts? Okay. Okay. So okay, this is the simple, very simple thing that a 0 dB value means that in terms of whatever unit you are given, it will be 1, right? If it's a 0 dBm, then the power can be said as 1 milliwatts. If it's 0 dB ampere, 0 dB of current, let's say, then it's a 1 ampere. If it is something else, then it will have one of that unit. Okay, got it? So here it was given 0 dBm of power. If you convert it into milliwatts, it will be 1 milliwatts. Okay, so yeah, first what you have to find out is R radiated. So R radiated formula already discussed with you, that is 80 pi square dl by lambda whole square. So here 80 pi square dl by lambda square, dl by lambda, it's already given. Current length element of length of current element is lambda by 50. It is already in terms of lambda. Here you will put it. You will be able to find out R radiated, right? R radiated for this current element is how much? 0.32. Okay, okay. I will try to tell you what is happening, right? So that you will be able to understand what has happened and what you were supposed to find out. Okay, I feel like you were not able to understand what has happened and what you need to do. Okay, see, a power source was given. Okay, it was how much? 1 milliwatts value. Okay, it was connected to a transmission line. It has a 50 ohms, right? connected, it was connected to a current element. Now this current element was, let's say, radiating. Okay. Uh, okay. The length of this current element was 5 lambda by 50, not 25, lambda by 50. Okay. It was asking to you the power radiated. Let's say the P radiated, it was asking to you. So first thing is current getting, power getting reflected from this edge. Okay. First thing was that. Okay. So uh, earlier I said that you have to find out the reflection coefficient from here. You have to find out the reflection coefficient from here. But since it's already 50 ohm and here it's not given how much R this current element has, right? But we it's a thumb rule, you can say, that if a transmission line has a 50 ohm 50 ohm impedance, then we can say that it has a good impedance matching. So here we have a good impedance matching and the power is reaching till here. Okay. But the R radiated, now from here it is going in the air, right? It's a free space, it's a air. So here we don't know the radiation, R radiated. Is anyone with me? Are you guys able to follow what I'm saying?
Yes.
Right? Yeah. Anyone else? Are you able? R radiated, yes. Ilango, very good. Uh, so in the free space there will be, if a current carrying conductor is kept, right, there will be electric field, there will be magnetic field, and we can find out the power radiated. If we can find out the power radiated, if we say that it's a current carrying and conductor, can we, will we be able to find out the resistance for that, right? Corresponding to P radiated, there is R radiated. In lecture number 4. Yeah, in lecture number 4, if you have gone through the lecture number 4, you will be able to find out R radiated, P radiated. So what is happening here is, from here to here there is a good match, yes, but from the current carrying conductor to the free space, is there a, I give you a hint that there can be a mismatch here, but it's already 50 ohm here, 50 ohm here. So there is no mismatch here, but there is a mismatch here, right? From here it's going in free space. So it is possible that some of the power is getting reflected back and some of the power is getting radiated. So you have to find out R radiated. Then whole power will be coming to here, 1 milliwatts. When you find out R radiated, will you be able to find out reflection coefficient will be given like how? R radiated minus the uh, resistance of this current element, which is 50 ohms, divided by R, R plus 50. Okay, I will write it properly. I'm not able to write here. So you have to find out the radiation resistance. Formula is already given to you here. element, length of current element is given to you. You have to put it here. You will be able to find out R radiated. Now the reflection coefficient. Reflection coefficient will be how much? R radiated minus 50 ohms divided by R radiated plus 50 ohms. This is R minus 50 upon R plus 50. Any doubt here? बताओ यार, कोई डाउट है क्या किसी को?
No, ma'am.
So here what we are getting, the reflection coefficient we are getting is 0.99. So this means it's quite high reflection coefficient. Quite high reflection coefficient means what? That almost all of the power is returning back. Not much power is getting radiated. Almost all of the power is returning. Okay, got it? Got this much? Guys, are you able to understand this much? So now 1 milliwatts is given by the source, right? From that, around 0.999, not 0.9, 99% of the power is getting reflected back. Now can you find out how much power is being radiated? It's now, right? I have written the formula. Put all the values, you will be able to find out the radiated power. Okay, you know the power source of source power, you know reflection coefficient. You will be able to square the reflection coefficient, then you will be able to find out power radiated. Now tell me how much power radiated. So the incident power is 0 dBm, which is equal to how much? 1 milliwatts. Hence the transmitted power is 1 into 1 minus 0.99 square. Put the value equals to 0.02 milliwatts. So 0.02 milliwatts means how much? 10 log 10 log 0.02 will be equal to minus 16.99 dBm. So minus 16.99 dBm. So approximately it is equals to minus 16.32 dBm. So option C is the correct answer. Okay. Point one. Yeah. So you guys, are you able to follow up? Are you able to follow what I said? Guys, जल्दी बताओ यार. Yes. So understood, right? What happened? Very good. Understood everything, right? So there was a transmission line and then there was a current carrying conductor. So you have to find out the reflection coefficient at the transmission line and the current carrying conductor. Then you have to find out the reflection coefficient at the current carrying conductor and free space. So since it is already 50 ohm for the transmission line, there is no reflection. It is a good match, and getting the current carrying conductor and the this thing, and the transmission line does not have any reflections. Where is reflection at the current element and the free space? So first you have to find out the reflection coefficient. How will you find out? You will find out by the getting the value of R radiated, resistance of the radiation. Then you will be able to find out the reflection coefficient. Then you will be able to find out how much power gets reflected back and how much power gets radiated. Once you get that, that is the answer. How much power is getting radiated. Okay. I hope you understood what I have to try to uh, tell you. Anyways, ठीक है. Go ahead and try to find out question number 5. So a horizontal infinitesimal electric dipole of constant current I naught. Again, a horizontal infinitesimal electric dipole, right? Electric dipole of constant current I naught is placed symmetrically about the origin along x-axis. The components of magnetic field far field will be. You have to find out the components of magnetic field. So let's say this is x, this is y, this is z. Okay, and this is our current carrying conductor. Okay, this is phi and this is theta. Okay, got it? This is phi and this is theta. Now it is asking to us components of magnetic field in far field. So let's say we are trying to find out at point P components of magnetic field. Okay, so this will be R. This is let's say R dash distance apart. Then this will be R minus R dash. Then you have to find out the value of the components in terms of theta, h theta, h phi, and hr. Okay. I'm giving you 2 minutes. Okay, think about it and then we'll discuss. Okay.
Can you please show the options, ma'am?
Yes. And okay, so here is a hint. Right? Here is a hint for you. Read it. Very good, Shyama. First, you need to notice that this is Cartesian coordinate. So for you have to put it in a spherical coordinate system, convert it into spherical coordinate system. Then you will be able to find out the magnetic field. Okay. Done. See, you know this, right? Del cross A. A, you know, first you have, this is in Cartesian coordinate. So first you convert this into spherical coordinate using this formula given here, right? Then do del cross A. By doing del cross A, you will be able to find out every H, that is HR, H theta and H phi, you will be able to find out after doing del cross A, curl of A. Okay. First, you know this, convert A into spherical coordinates using this. Once you convert all the spherical coordinates using this, put a del cross A and you'll be able to find out H. Okay. Okay, 2 more minutes. Anyone going to give me answer or okay, chodo. That the vector magnetic potential. See, so this is how the current arrangement is, right? This is the current element in x direction. This is z and this is y. If we go in spherical coordinates, then this will be phi, and from z it will be theta. Okay. So the current is a x directed, right? So therefore the magnetic potential will also be x directed and it will be symmetrical for theta and phi. So the vector magnetic potential will be about I naught a x direct r is I naught dl upon 4 pi r e to the power j k naught r. Okay, this sir would already have discussed with you, so I don't think there should be any doubt here. He would have derived this for you, right? He would have derived it. So now this is in Cartesian coordinate. So first convert these in spherical coordinate using this formula. So we already know that uh, when we try to find out AR, A theta, A phi, which is spherical coordinates, spherical system, coordinate system for to convert a Cartesian coordinate system. How? Is equals to sine theta cos phi, sine theta sine phi, cos theta cos phi, cos theta sine phi minus sine theta cos phi 0 ax ay az. Okay. So now the components are in spherical coordinate system. You will be able to find out AR, A theta, A phi using this formula. So AR is this, A theta is this, and A phi is this. Okay. Now what we have to do is, we already know that magnetic field, that is H. H can be given as del cross A. curl of, if we do curl of A, we will be able to find out the, what we will be able to find out? Magnetic field, right? So then we'll do curl of A. Formula is 1 upon r squared sine theta, r a theta, r sine theta a phi. You know this value. We'll put it. We'll be able to find out the value of hr, h theta and h phi. H phi, not theta, it is h phi. Okay. So basically, if it is going through x, right? So our r is also in this direction. Our r is in this direction. So we won't have any element in r direction, right? hr will be 0. Okay. And we will have a value of theta and phi. Okay. So hr will be 0, but we will get the value of h theta and h phi. So basically what you have to take out from here is h is equals to curl of A. Curl of A. This is what you have to take out from here. Alright. Other things is like pretty, sir would have already told you about this. So I uh, I don't expect that you solve this and get up to this value. No, I do not expect you to solve this much. What I do expect you is you know the value of vector magnetic potential in far field. I want you to know this value, and I want you to know how to find out the magnetic field, that is curl of A, curl of vector magnetic potential in far field. Alright, this is what is expected from you. Anyways, chalo, let's try to solve next question. I don't think I will be able to finish whole assignment today, so we will take uh, other questions from this assignment in the uh, next live session, and plus we will I will try to solve all the questions for the assignment 2 as well. Okay, so anyways, let's try to fatafat finish question number 6. So again, an infinitesimally small dipole of length lambda by 100. You have already gone through so many. You have already gone through so many dipole kind of current carrying element, uh, right? I hope that you will be able to solve this question. Okay, and is operating at 100 megahertz. So this time the current is AC. It is driven by uniform current I. Determine the magnitude of magnetic field at a distance 10 meters from the element. Okay, so it's a small dipole of length lambda by 100, right? It is z directed, operating at 100 megahertz. From here, from 100 megahertz, you will be able to find out omega, right? It is driven by a uniform current I. Okay. Determine the magnitude of magnetic field at a distance 10 meters from the element. So from a point P, which is at distance 10 meters, have to find out magnitude of magnetic field. Okay, so h phi is I dl upon 4 pi e to the power minus j k naught r sine theta by r square. You already know the value of r, you already know the value of dl, you already know the value of k naught. K naught is how much? 2 pi by lambda, right? K naught is how much? 2 pi by lambda. And you already know, can you find out the value of lambda by the frequency? Frequency is how much? 100 megahertz. Will you be able to find out the value of lambda? After finding out k naught, put all these values here. You will be able to find out h5. Okay. See, first thing is it's already given current in I terms, right? So whatever the option will be, it will have I, right? Because we don't know the actual value of I, right? So either option will be C or D, isn't it? Because these option A and B does not have any value of I. Anyway, so this is the formula. Put all the values here. You will be able to find out. Is value of theta given to you? No. Is value of r given to you? Yes. So the options will have I and sine theta. Others values are you can put k naught, you can put dl. R and r you have to put. You will be able to find out the value. anyone solve? What is 3 meters? Okay. 3 meters is not answer given here. It's microamperes per meter, microvolts per meter. Actually, you didn't even need to solve this question, right? Listen to me, okay? So either you solve this question or uh, you use a method, right, where uh, you can get the answer directly. So here, first thing is a magnetic field is asked, right? Magnitude of magnetic field is asked. So we already know that the magnetic field has a unit of volts per meter, right? Amperes per meter. Magnetic field has a unit of amperes per meter. So either the answer is option A or the answer is option D. Okay. First thing we got is option B and option C won't be correct because the unit is given. It's in millivolts per meter and it's microvolts per meter, which is wrong, right? Another thing to notice is in option A there is no variable given to you, whereas we already know that we don't have the value of I and we don't have the value of sine theta. So anyways, the magnetic field will have I and sine theta component. Alright. So option A won't be correct because it's directly a constant given to us, but we know that there will be a variable I and sine theta since it is not given in the question itself. So by this value, by this method, we know that option D will be correct. Okay. Because option A, B, and C won't be correct, option D will be correct. So this is a trick of the question. By using this trick, you can save your time and do not need to actually solve the question. You can directly use the trick and you will be able to find out, right? Now, if we try to solve this question, then we already know the value of h phi. Value of h phi is ideal by 4 pi e to the power minus j k naught r sine theta by r square. So now the magnitude will be magnitude of this value. So the magnitude of this value will, what will happen? This term will be removed, right? Because the magnitude of this is 1. So directly ideal by 4 pi into sine theta by r square. Now the value of lambda can be determined by how? C by f, right? Can you find out the value of lambda? Yes. It's already 100 megahertz given to you. Frequency f is given to you. How much? 100 megahertz. Lambda is how much? C divided by f. So C is 3 into 10 to the power 8, that is speed of light divided by 100 megahertz. So lambda is 3 meters. Now you substitute all the values, that is dl, r and lambda, and you will be able to find out h phi, which is 23.87 modulus of I sine theta microamperes per meter, which is option D. Got it? Are you able to follow what I said? Guys? Sorry, D because milliamperes. Yes. Yes, Raj. Good. Yeah, good. Okay, so I feel that time is up. So I will take up question number 7, 8, 9, and 10 in the next session. Okay. Uh, Tell me one thing. Do you want a session in between the next session? Because you will have to submit your assignment before next week. So if you want, I can take a session in between to solve question number 7, 8, 9, and 10, so that we save time in the next session. Or do you want to come in the next session and we can continue from here? So this assignment and the next assignment, how do you want it?
Ma'am, it's better to have a
I'm not
in-process
not
conversation.
Tomorrow is the last date of assignment 1. Okay. All right. So if you want, I can give you one session tomorrow for 7, 8, 9, and 10 question. Or if you want, I can skip it. Like, tell me how you want. I will record the session. Uh, I will record this whole session and I will put it on YouTube. Okay, on my YouTube channel. So there you can come back and see this assignment, right? And question number 7, 8, 9, and 10 as well. So it will be there on my YouTube channel.
Ma'am, please, can you tell your YouTube channel name? Okay, sure, ma'am.
Okay, so I'm ending the session right now here because it's already 2 hours and I don't want you to just slug. Okay. Yeah, so you guys can come tomorrow, or I can do one thing. I can just record it without anyone and post it on my channel, and there you can go through it. How do you prefer? Reply something in the chat. I won't. Yeah. Jyoti, are you saying something?
Yeah, ma'am. In the assignment 1, they asked to calculate vector potential. Then we have some doubt in that.
Okay, what do you have doubt? Vector potential, magnetic, electric, what? Okay, so all right, I will try to post question number 7, 8, 9, and 10 on my YouTube channel before tomorrow 11:59 p.m. Okay, and then you guys can go through it and try to solve assignment 1. All the best for assignment 1. Okay, and it will be similar to these questions only. There won't be much difference. I will post the solutions and this thing in my YouTube channel that I will post. I will give you the solution. So even though if I don't teach you, the solutions will be given to you. So for question 7, 8, 9, and 10, so you can directly go through it and try to solve the question. Okay. try to solve the assignment 1. Okay, and all the best. And this is uh, that's it for today. Okay, bye bye. Bye bye everyone. If you have any doubt, you can ask me, and or I will leave the meeting if you have any doubt. No? Okay, then all the best. Bye.